Okay, in this video we will learn the basics of ECG and we will note why there is basic positive or negative deflection we find in PQRST in case of ECG. Taking the simple example, suppose this is a normal ECG, then here comes your P wave and then PR segment and slight Q deflection, R, S, and here's your ST segment and here's your T, isn't it? So what you can understand from here is that always look at the PR segment. This is first of all we will talk about the waveforms. What are the waveforms? This is called P wave, and this one here is called Q. It is called R. It is called S, and this is called T, isn't it? So here we have our P wave, Q, R, S, T, isn't it? Let me draw in a big size. So it is our P. Okay, so this is your P wave, this is your Q, this is your R, this is your S, and this is your T waves. So this is the basic fonda of ECG. And when you see here to here, so somewhere in some cases you don't have Q wave, so you can also bring it to the R when Q is very small. Then this is called PR segment. Okay, this is called PR segment. Okay. And when you take from start of the P wave to here, this is called PQ interval. Okay. So first of all, you need to understand what is PR segment and what is PQ interval. Likewise, this is called ST segment. And from here to end of the T, it is called ST interval. So this is ST interval, this is ST segment. So these are some basics definitions or nomenclatures that you need to understand. Now we will talk what are the significance of different waveforms that we find in ECG and correlate that with the changes that we see in the myocardium or the heart. By that what I mean to say is that suppose here is your P wave, QRS, and this is T. So what is P wave? What does P wave signifies? Always keep in mind, P wave signifies the atrial contraction. No, sorry. P wave signifies that the electrical activity in the atrium. First of all, there will be electrical activity in the atrium, then only comes the atrial contraction. So basic fonda is that before any contraction, you first need to find the electrical changes. So before atrial contraction, you find the P wave. So what is P wave basically is that suppose this is your heart. I am showing the schematic heart, and here it is your SA node, and it is your AV node here, and this is a bundle of his and Purkinje fibers. They run like this. So when the electric impulse gets generated from here, then there will be the gradual P wave formation. So the basic fonda is P wave is the electrical activity in the atrium. And what is this PR segment? PR segment is nothing but the continuation of the propagation of electric impulses in the atrium. Okay. And what is Q wave then? Q wave is nothing but, suppose this PR segment, I need to address it once again. P wave. P wave is basically nothing but the electrical activity taking place in the atrium. So when the electrical activity they are running in the atrium, there will be the formation of P wave, isn't it? And what is PR segment? So during an AV conduction, when the impulse reaches to this AV node, there will be like the magnitude of electric flow is very small, and that flow of electricity will not be picked up by the ECG. So there will be flat line, and this flat line is called isoelectric line. So always keep in mind this isoelectric line because it is important in case of especially finding the MI and J point, where to take the SI where to take the isoelectric line. So this PR segment is your isoelectric line. So always keep that in mind. Okay. So basically PR segment signifies that the electric signal has reached to the AV and there is some delay, and then basically what is going on is there the ECG is not being picked up, or the electrical activity in the AV node is not being picked up by the ECG. So there is flat isoelectric line. Is it clear? If you may ask why is there delay in the electrical conduction in AV node, I will draw a slight diagram. So this is your AV node. What it happens is that in AV node the cells are arranged like this. So when they are arranged in like this pattern, when the electrical activity propagates from up to down, there will be resistance. And there are, suppose in other cases of myocardium, there will be cells connected like this. So during the transmission, it will be easy transmission. But in case of AV, they are in perpendicular form, so there will be more resistance. And another thing is that there is less gap junction in AV node. However, in other myocardium or SA node, there are higher gap junctions, so electrical conduction is fast, where in case of AV node, it is delayed. This thing need to be kept in mind.